Hello and Happy New Year from all of us here at The Naked Scientists. Our brand new series starts next week on January the 13th, so until then, here's the latest Ask the Naked Scientists, our weekly science phone-in show with Sue Marchant.
Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas?
Why do some things glow in the dark?
Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Chris Smith. What's new in the world of science for you?
Well, today's exciting news is, of course, the announcement of the RAE, the Research Assessment Exercise. Now, this has been going on for 7 years, and universities all around the UK have submitted their entries. 220+ thousand assessments were submitted by academic institutions around the UK. And this is a sort of scoring and rating system which is used to scrutinise the quality of Britain's academic research output. The idea being to work out who's good and who's the best. And the government then uses that data, and research councils use that data to work out who deserves extra perks, in other words, where the money goes. And we deserve a pat on the back in this area because Cambridge University has come out as number one in the country. Some would say a bit predictably, but of course that doesn't come without hard work. And so all the people who are at Cambridge University deserve a big pat on the back, because what that's showing is that the University of Cambridge's research output is of extremely high standard, and not just in this country but internationally. In fact, looking at most of the league tables, Cambridge University is ranked as the best, or at the very least second best university in the world, alongside Harvard in America. So we've got every reason to be proud, because of course it's where we're all living in this area, in this part of England. It's actually going to be the last year that they do this RAE, because it's a huge amount of effort on the part of the institution, and so they're going to start probably finding a new way to rank academic institutions, maybe look at them from a different perspective, or work out a new way of working out who's good or who's the best, because it's not really sustainable. And it's also, some say, a bit dubious what happens, because when universities know that there's money on the end of something, then what can happen is that they can resort to various tactics to try to make sure that their quality is high in certain areas in order to secure better funding. And the way that they might do that is by recruiting somebody from another university who's very good, and then that person counts towards the RAE score for their new institution. So in other words, if you wanted someone really good on your radio station, you'd phone up Sue Marchant and say, hey, come and work for radio whatever, and then you'll make us look really good and make us sound good. And so, as a result, universities can end up spending a huge amount of money to lure people in, because they have to give them a very juicy incentivisation package to lure some scientist in, maybe from another country even, so that they bring their laboratory group and their research track record with them. And, of course, that means the university is having to spend a fortune to get money back. And people question the ethics of that, they question the sensibility of that, because it's a huge, great money go-round, and it's dubious whether or not it really is the best way to go about things. And so I think people are saying, I think we need to re-examine this and find out whether or not there's a better way to rank out the prestige and quality of our academic output, and how to size up what universities have got on offer.
Right, it's time now to ask Dr. Chris the questions, your questions. Andrew in Cambridge, Dr. Chris, says, I often wake up with sleep in my eyes. What I want to know is, what does the body make it for, and what's its purpose, that sleep that you get in your eyes? Chris?
Yeah, well, tears are the source of sleep, and it's in fact tears that have evaporated a bit or dried out and left behind the other things that go with them. Because tears, although they may appear to be just water, are a complex mixture of salts and proteins, and those proteins include antibodies and mucus, a slimy chemical called mucin, which is produced by mucus-producing cells both in the eyelids and also in the duct that supplies tears. And the idea of mucus, of course, is to lubricate the eye in the eye socket, and also lubricate the lids as they roll across the surface of the eye and back. And there are also enzymes called lysozymes in tears, and lysozymes can break down components of the cell walls of bacteria. So they're a very good way of keeping your eyes clear of infection. And when you go to sleep, the tear production goes down a bit, in the same way that saliva production goes down when you're at sleep. And as a result, because you're producing fewer tears, you're blinking much less, and therefore you get stasis or pooling of the tears in certain bits of your eyes. And in other words, little bits of tear can leak into the corner of your eye, and it evaporates because, of course, your skin is warm, and the water evaporates off, and it leaves behind those collections of salts and mucus and proteins, and they dry out and form almost like a bogey, but in fact it's dried tears, and that's the sleep. And you'll notice that this gets a lot worse if you're in a dusty environment. If you've been working on a farm or in a dusty environment during the day and you go to sleep, you'll find this may be exaggerated. If you get an infection, you'll also notice that the tears are exaggerated because you're producing local inflammation in the eye, and this produces more debris which gets lodged in the tears. And also, if you have an infection in the nose, this can spread into the duct that drains the tears away down into your nose. It can block it off, and this means that tears don't drain so well, and they're more likely to form sleep. And that's why you can get an exaggeration of that when you have either an infection or sometimes allergies as well.
Right, OK. Thank you very much, Dr. Chris. Our next question, Ian in Essex says, what are the best ingredients to look for in olive oil, such as fat, for example? Should I be looking at monos or polysaturates?
Yes. Well, the thing about olive oil is that it's very rich in what are called monounsaturates, MUFAs, monounsaturated fatty acids. And the best olive oil is allegedly the olive oil that's first pressed, the extra virgin, because when you first press the olives and then you take the oil off, the first oil to come off is the freshest, it's also the finest, and is said to be the best for you in terms of its antioxidant profile and its monounsaturated fatty acid profile. In studies, olive oil seems to be linked to a lower rate of harmful, bad-for-you cholesterol when you eat fat in the diet, and therefore seems to be protective compared with if you eat saturated fat. Now, saturated fat is animal fat, for instance, lard. So if you eat red meat, there's a lot of saturated fat in there. If you fry up food in lard, that's a lot of saturated fat. And this is linked to higher levels of bad-for-you forms of cholesterol, and this is associated with a higher risk of heart disease. So olive oil is a good thing because it seems to be linked to, if you consume modest amounts of olive oil, a better cholesterol profile. And the evidence for that is epidemiological. Scientists have been following populations around the world, looking at how their lifestyle, their diet, and other things that they do relates to how long they live and what sorts of diseases that they get. And a pattern that was picked up very early on in the early days was down in the Mediterranean basin. And what doctors and epidemiologists noticed is that people who live in the Mediterranean tend to live a very long time. And in fact, there's this thing called the French paradox, which is where people seem to live longer than they ought to based on some of the other rubbish that they eat. And to get to the bottom of why this paradox exists, they started studying people's dietary habits and other sort of lifestyle factors, and found that people who lived the longest tended to eat diets which contained olive oil, also contained small amounts of red wine in moderation, and these people tended to lead a fairly unstressed life. So those are the ingredients of a healthy life by the look of it. So olive oil does seem to have an effect in terms of reducing your risk of the biggest killer, which is heart disease.
I do like my olive oil, and I do like a little bit of red wine, both in moderation, of course. Now, one here from Harry. Can you ask Dr. Chris, how long does the body take to heal, the breast to recover completely after an operation? Because each time I cough, my chest hurts. It's been nearly 5 months since I had an operation, and that's from Harry, Chris.
Yeah, well, normally you'd expect things to heal up quite quickly, but Harry doesn't say what the operation was on his chest, and if they had to actually open up his chest cavity, for instance, to do a cardiac bypass, where you take a piece of vein and branch it across a blockage in an artery supplying the heart, or you reroute an artery from the wall of the chest to bypass a blockage supplying the heart, those kind of things are quite radical surgery. And because you're relying on bones to knit back together, sometimes other tissues get damaged in the process. This can take a while for things to heal up. and it can remain painful for quite a long time afterwards, especially, as he says, with sudden explosive movements like coughing or sneezing or sudden abrupt movements. Normally, if you have an operation just to soft tissue, like skin, this heals up very, very fast, because skin is full of stem cells, and the stem cells, as soon as you cut through the skin, the cells can detect the fact that there's a local breach or piece of damage, and they start to divide or grow very, very rapidly. And as soon as they start doing that, the consequence is that the wound heals up. Now, what can happen when you have fairly major surgery is that you can damage elements of the nervous system. And some nerve fibres, when they're injured by an operation, don't recover properly, and they, in fact, die. And this is very common with the nerve fibres that convey pain and temperature sensation. And because the nerve fibre dies, because it's been cut during the operation, where it would normally connect in the spinal cord to relay nerve cells that tell the brain what that nerve is feeling, those nerve cells in the spinal cord no longer have any connections running into them. And other nerve fibres that supply a similar area of the body but do a different job can sometimes branch and resupply those cells that have been denervated or had their nerve supply cut. And this means that where previously you had to have pain or high temperature to stimulate those nerves in the spinal cord, now it's whatever job the new nerve supply does. And this might even be just stroking or fine touch can drive those nerve supplies in the spinal cord. And as a result, people feel inappropriate pain. And this is a condition called causalgia. And it's very, very uncomfortable. And it can be associated with very radical surgery or very severe injury. So it might be that that's partly what's going on in Harry, but it might be that it's just that the operation itself is taking a little while to heal up. It could be either of those two things, and it's worth seeing someone who's a specialist in pain, because you treat the two in a totally different way, because the treatment for one of those disorders will not work for the other. So it's important to get the diagnosis right so he knows what the best course of action is.
Now, Graham in Essex is wondering about the Nova virus that is going around at the moment. Can this stay inside the body dormant for a space of time and then come back? Good question. Chris?
Yeah, this is norovirus, which is also known as various names: winter vomiting disease, Norwalk virus, Norwalk-like agent, small round structured virus. If you actually get some samples from patients who are infected with this, and to put it in perspective, and this is a bit disgusting, shut your ears if you don't want to hear, every centimetre cubed of faeces from someone who has diarrhoea because of this agent has got more than 1 million and possibly as many as 100 million viral particles in it. Ew. And these virus particles are absolutely tiny. They're 30 nanometres. So that means they're 1/30,000th of a millimetre across. So imagine how many of those you could cram on the head of a pin. They're so tiny, they're smaller than some particles of smoke that you see coming off the end of a cigarette. And this means that when someone has norovirus infection, and it makes you have profuse projectile vomiting and diarrhoea, which suddenly comes on out of nowhere, you make a splash or a puddle on the pavement, and up comes a sea or a sort of a miasma of these little particles, millions of them floating around in the air. And they are incredibly tough, because they don't have an envelope, they haven't got a fatty layer around them. They're just like a protein husk, which is very, very tough. And this means they can survive for long periods of time in the environment. And they drift around in the air, they settle on surfaces, and especially if this happens in, say, a lavatory, someone touches a surface after someone has been ill in that lavatory, perhaps even a day or maybe even a week beforehand, and you get the virus onto your skin, on your fingers, and it can survive up to 7 transfers from one surface to another. So say I touch it and I've got it on me, I shake hands with you, you can have it on you, you can shake hands with someone else and they'll get it, and it can transfer up to 7 times like that and remain intact and infectious. And the infectious dose is as little as 1 particle. It's incredibly infectious, and it gets into your body, and as soon as it gets into the stomach, it senses that it's in the right place. The acid in stomach acid probably activates the virus. It's a bit like pulling the pin on a hand grenade, and this tells it, right, you're in the right environment. It then gets into the small intestine and starts locking onto the cells that line the small intestine, and it hijacks them, and it turns them into virus factories. Each cell then starts pumping out thousands, if not millions, of copies of this virus, which are then shed upwards and downwards for as long as you have symptoms. And usually you shed the virus in appreciable amounts for several days. But if you look really closely, you can find people carrying it for maybe up to 3 weeks.
My
So
goodness.
the moral of this story is that you should, if you have had a history of this agent, you should be very careful with your hygiene because you can easily infect other people. And although you may get better quite quickly within 3 days, the virus mutates very fast. So there's no guarantee that you won't get it again 6 months later. So you need to practice good hygiene because the same technique that stops you giving it to someone else will also keep you safe in the future.
Thank you, Chris. We've learnt an awful lot about that now. How scary is that? Let's welcome Mark onto the programme. Hello, Mark.
Hello.
Hello there. Right, we've got Dr. Chris on the line for you. What's your question?
My question is, I suffer from 2 spine problems. One's something called bilateral pars deficiency, leading to segmental instability and association muscle spasm is the first one. And the other one, the vertebrae have actually split apart and moved, so one half's moved forward. Okay?
Is that spondylolisthesis?
That was one name that was given to it.
Excellent. Okay, I think I know what you're talking about. Okay.
Right, but I don't think it covers for both of them. There was a revolutionary operation done at Addenbrooke's, fairly recent, so I've been informed, where they did keyhole surgery on a spine problem. Now, do you know what that operation was? And see, I know what I've been told, but what else is available for an operation like this?
Okay, well, let me talk in general terms because obviously, Mark, I don't know much about your case, and forgive me, it's very difficult to make diagnoses and to understand what's going on when you can't actually take a look at somebody. So I'll talk in general terms, but in terms of spinal surgery, there are a number of things that can go wrong with the vertebral column. The vertebral column is a series of bones that are connected together. They stack up like building blocks that you find in a children's toy box. And as one person put it to me, that it's a bit like a bicycle chain, in fact, the way they're all linked together, and they're supported by guy ropes, which are the muscles that hold them in place. And these bones stacked up on top of each other can move relative to each other sometimes. Various injuries can provoke that. Sometimes there can be a degenerative thing that makes this happen. Sometimes there can be a traumatic thing, you have car accidents, or injuries at work, or sometimes there can be a predisposition that the vertebrae don't sit stably on top of each other and one of them can slip forward, and this can occur in the lumbar, the bottom of the spine region, and when this occurs it can be very painful and it can also impinge on other nerves, and this is part of the reason it's uncomfortable. One of the other things that can happen in the spinal cord and the spinal column is that as we get older, the bones where they knock against each other can develop arthritic changes, and this can lead to the formation of new bone called osteophytes, and these bony protrusions can begin to impinge or block or press on nerve roots, and this can be uncomfortable. It can also restrict movement of the spine, which can be uncomfortable, but generally they're quite common. Lots of people have that. The other thing that can happen is you can get slipped discs. Now, between each of those bony bodies are vertebral discs, and these are cartilage, which has got a soft gelatinous centre and a very fibrous, tough outside. And sometimes when too much pressure is applied down through the spinal cord, for some reason a weakness appears in the outermost part of the disc, the tough fibrous bit, and the jelly in the middle bulges backwards through the weakness, and the bulge presses on some of the nerves coming out of the spinal cord, and you then feel pain in that part of the body supplied by that nerve. So if this happens in the part of the spine, the lumbar spine that supplies nerves to the back of your leg, you get sciatica because the sciatic nerve is being squeezed. You feel pain in your leg, but actually there's nothing wrong with your leg. It's just that the nerve that's supplying that region is being squeezed up near the spinal cord, and this makes you think that there's pain in your leg. So there's a whole range of different things that can happen to your back, and they can occur very, very frequently. I think the point prevalence of backache is about 1 person in 5. So in other words, if you look at the general population, about 20% of people have got a backache at any given time. When people put their back out, what often can happen is that you can twist or get into a funny position and maybe squeeze a nerve, and you then get a muscle spasm, and the muscles that are propping up the spinal cord, and the vertebral column rather, at whatever point, can go into spasm. And in the same way that you can get a sort of neck spasm when you get a stiff neck, the same thing happens in your back. And this makes the bones and other muscles get into a funny position, and it can be very uncomfortable. It can also squeeze nerves, and that's what people talk about when they say, I've put my back out. This can usually be treated with some anti-inflammatories, some muscle relaxant drugs, and some rest for a while, and it normally, luckily, gets better. In some people, these kind of conservative measures don't work, and you need to resort to surgery. And the kinds of surgeries that are available are determined by the kind of nature of the problem that you've got. So if you have a very severe and unstable bone problem in the spine, for instance, say you've got a degenerative problem like osteoporosis and something's collapsed, or you've got a fracture in the spinal bones and they're moving where they shouldn't. Sometimes the only way to remedy that is to go in and you fix pieces of metal to join different bits of the bone together. TB, for example, used to erode the bones of the spine, called Pott's disease. This was very common historically. We see less of it these days, thank God, except in the third world where you still see this. And under those circumstances, the best way to treat that is by treating the infection. Then sometimes you stabilise the spine with metal implants. Again, the condition I mentioned at the beginning, spondylolisthesis, this is where some of the vertebral bones at the bottom of the back, one of them can slip forward on another. Sometimes the only way to do this to fix this is to fuse two bones together. So in other words, you put the bone into the correct position and then you use some metal work to bolt it in place. And so you lose a bit of movement, but you make it much less unstable, and that's much safer, and it's also much less uncomfortable. So I know that doesn't give you precise answers about your precise problem, but I can't really do that anyway. But I hope that that's generally useful.
I hope that helps, Mark.
Thank you, then.
Take care. Bye-bye.
Okay, bye.
Bye-bye. Another one here that's come from Dan in Toaster. He says, recent news reported new species of creatures. Hopes it's not a silly question, but doesn't that come under evolution? Chris?
Well, not really, because it depends where those creatures came from, because we certainly don't think we know about all the creatures we have on Earth, and we certainly don't think we know where, well, we certainly don't think we've studied and discovered every single creature that ever existed. So there are inevitably many, 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 many creatures out there in the wild that we don't know exist. Now, that's less likely in well-developed countries, but in tropical rainforests and in less developed areas of the world where we've not had an impact on the environment, and where people don't go so often, there are inevitably species there that we just haven't ever come across, but doesn't mean they don't exist. So one mechanism for discovering new species is because they've always existed, but we just didn't know about them. Then there is the question of new things popping up and evolving, and there's no doubt about it that new species are coming along. And, for instance, if you look at, there was a famous experiment that was done in America. For the last 20 years, a scientist in America has been growing E. coli, the gut bacterium, in his laboratory. And he grew this bacterium in very restricted circumstances in a petri dish for 20 years, so thousands and thousands and thousands of generations of E. coli. And he found by the end of his experiment that he had evolved his E. coli into a whole new species of bacterium, which had metabolic abilities. In other words, it could digest things that E. coli couldn't start with. So it had evolved entirely new abilities that the starting bacteria hadn't. So evolution is undoubtedly happening, and it's certainly disclosing new forms of life, probably more commonly at the small scale, because we're not looking over a long enough time span to see it on the more macro scale, but it's certainly happening, and that's certainly the case.
Wow. Get ready, because here comes Tony. Hello, Tony.
Good evening.
What's your question for Dr. Chris, Tony?
Well, my main question, I've got two for the price of one, if I may. Why do we have Adam's apples? Are they any use?
Well, you'd hope so, Tony, because if you didn't have it, then you wouldn't actually be able to talk to me, because the Adam's apple is your voice box. It's more prominent in men because us guys have a slightly lower voice than women do. We tend to have lower frequencies, and that's because the vocal folds are bigger and floppier, and they vibrate, therefore, at a lower frequency than they do in females. That's why women don't have an Adam's apple that's so pronounced. But if you were to open up the skin of the neck and look, the Adam's apple is this chunk of cartilage which is at the top of your windpipe, and it opens up at the top of the windpipe and projects forwards. And inside that are muscle flaps, which are your vocal folds, the vocal cords. And they're the ones that get tensed and relaxed in order to help you speak.
Well, I'll be blowed. I never knew that. That's very interesting indeed. And ladies have got them, but they're smaller.
Yes, that's right. It's one of those organs which demonstrates what's called sexual dimorphism. In other words, there's a difference between the male and the female sex. It's a bit like if you look at deer, male deer have antlers and female deer don't. Well, female gorillas, for example, are much smaller than male silverback gorillas, which are huge. Now, they've both got very similar DNA, except that the males have got testosterone washing around in them and the females don't. And this effect of this hormone is to change the characteristics of certain tissues in the body. And in men, for example, you tend to get a hairy chest. That's down to testosterone. Another effect is that it causes the vocal tract to develop more, and this is what gives men a lower voice. And the evidence is that women find a low voice sexy, probably because it's an indirect...
Really?
Well, quite, yes, I notice everyone's suddenly talking very deep. But the reason for that is it's an indirect marker of how much testosterone you've got. If you've got lots of testosterone around, then you have a very deep voice, and as a result, you therefore are giving away your testosterone levels to women. You're saying, look, I've got so much testosterone, I can have a very deep voice. This must mean that I have very good testicles and are therefore excellent to breed with.
Do monkeys have them as well, then, as a matter of interest?
Well, of course, monkeys don't have the same developed vocal function that we do, but they do have a sort of vocal fold of types, yeah. That's how animals cough and sneeze. If you don't have working vocal cords, you can't actually cough. And if you look at some patients who develop lung cancer, one of the first signs that they've got lung cancer is that they can't cough properly. And the reason is that they've had a cancer which has damaged a nerve which flows past the root of the lung and goes into the neck and supplies the vocal cords. And the tumour damages that nerve and it paralyses one of the vocal cords, and the person gets a hoarse voice and can't cough properly because they can't close their vocal cords. And that's the giveaway that there's something going on in their chest, paradoxically enough.
Tony, you're an absolute star. Have a brilliant Christmas.
And you, dear. All the best.
Bye. Bye-bye. Oh, we love Tony. Now then, here's one from Kaz, actually, that's come through on the text. She has heard of a condition she believes is called Morgellons disease, where people believe they have a parasite under their skin, but most doctors do not believe in this illness. Does it actually exist? Have you heard of that, Chris?
Well, I went to a presentation at the hospital by somebody talking about this. It must have been about a year ago now. And it's interesting because people have these lesions on their skin which don't seem to heal properly. And when people look in these lesions, they find these fibres. And it was originally thought that this was something spurious, that perhaps people were rubbing things into these wounds, or that perhaps it was some kind of fibre from clothing or something. But there are a number of reported cases of this around the world now, and there's a Morgellons disease society that's been set up, and they're collecting cases, and people seem to think it is some kind of real entity, but I think it's one of these new kind of things that people don't really understand yet, and so they're not really sure whether it's real, or if it is real, what's causing it. But it's certainly something that people take seriously, and you can look it up. If you go on the internet and type in Morgellons syndrome or Morgellons disease, you can find it. I think there's been in the UK single numbers of cases ever, so it's very, very rare.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
And you can subscribe to Ask the Naked Scientists on iTunes or thenakedscientist.com/ask. We're back on the 13th with a question and answer show, so get all of your questions into us by emailing Chris at thenakedscientist.com. Until then, goodbye.